Hello, you are welcome to my channel. Our topic today is moment of a force. Moment of a force describe the turning effect of a force about a point or pivot. In our everyday life, we experience moment of force in many activities, such as opening a door, turning a water tap, tightening or loosening a knot with a spanner, and riding a bicycle by pedaling with the feet. In all these examples, two important factors determine the turning effect produced. First, the magnitude of the applied force. Second, the distance of the line of action of the force from the axis or fulcrum about which turning takes place. A large turning effect can be produced by applying a small force at a large distance from the pivot. This explains why it is easier to loosen a tight knot using a long spanner than a short one. The longer spanner increases the distance from the pivot, thereby increasing the turning effect. Experienced mechanics are aware that long spanner must be used with care because applying a very large turning effect may damage or strip the nut or bolt. The moment of a force about a point is defined as the product of the force and the perpendicular distance of its line of action from that point. Moment of a force is also known as torque. The SI unit of moment is Newton meter. Moment is a vector quantity possessing both magnitude and direction. When the force acts perpendicular to the object, moment m is equal to force times perpendicular distance. That is, m is equal to F times d. If the force is applied at an angle theta to the horizontal, m is equal to F times d sine theta. Let's take an example. A force of 20 Newton is applied perpendicular to a spanner at a distance of 30 cm from the knot. Calculate the moment of the force about the knot. F is equal to 20 Newton. D is equal to 30 cm, which is equal to 0.3 meters, the SI unit. M is equal to F times D. Substituting, M is equal to 20 times 0.3, which is equal to 6 Newton meter. Example 2. A force of 50 Newton is applied at an angle of 30 degrees to a spanner of length 40 cm. Calculate the moment of the force about the knot. Here, F is equal to 50 Newton and D is equal to 40 cm, which is equal to 0.4 meters. M is equal to F times D sine theta. M is equal to 50 times 0.4 times sine 30 degrees. M is equal to 50 times 0.4 times 0.5. M is equal to 10 Newton meter. So remember, the turning effect of a force depends not only on how strong the force is, but also how far from the pivot it is applied and the angle at which it acts. Understanding moment of force helps us explain many everyday mechanical action around us. If you have gained more clarity in this lesson, subscribe for more physics tutorial. See you in the next lesson.